What I have here is a flight controller. There are normally a lot of different types of flight controllers available in the market. You will find something like a 30 by 30 size, which is this, which has four holes of 30 millimeter each square, and you find the 20 by 20 size, which is this. It has 20 holes on the square. These are for the small builds, like you have a 2 and 2.5-inch quad you want to build, and you can usually use this, which saves a lot of space. As you can see, the size is quite small. Both have the similar capabilities of working in Betaflight and as well as INAV. I'll tell the basic things what are used here in flight controller and what are the connections basically you will find. This one in my hand, which I have, is the SpeedyB F405 version. Uh, this is the ARM chip. This is the main controller which we are using for our flight. Everything is controlled through this. It's the ARM32 F4 chip. What you have here is a USB type C connector, which will connect in a short time, and I'll show you how to connect to Betaflight as well. Here are the ports which you have here. The SDA SA line is for GPS, 5-volt ground. You have the LEDs BAT line for the voltage in to check your battery voltage. You have the buzzer connector, the BZ minus, BZ plus, and you also have the T6, the UARTs. This board itself have like 5 UARTs, from UART 1 to UART 5 to UART 6 here. And if you see here closely, if I can zoom in the camera, yeah, so there is a 9-volt pin also, which you can use, this one, which you can actually use it for your VTX. Some VTX power supplies usually give you a 5-volt output and 12-volt input, 12 to 26 wide range. But some VTX like SpeedyB TX800 needs a 5-volt dedicated power supply. I mean, more than that can fry the board. So some, you can use a 9-volt. This will filter your output a lot. I mean, you can use this not for the SpeedyB TX800, although, but you can use it for other VTX like GAP RC and Matic, and for other ones which are there in the market, like I can name few. The ones which have a lot of wideband and higher watts, like 1 watt to 3 watts. You can use those because those usually have a more than higher voltage in the VTX line. Then you have the VTX pad itself, which will connect the VTX pins. You have the UART T1 and R1, and here you have the T2 R2, where you can connect your ELRS connections, and also you can go for other connections like your any external sensors you want to connect, like optical flow, you can connect that. You have the cam connector for camera, which you will see for the FAV when I'll be building a quad in front of you, where you can see where I'm connecting the camera module. It goes directly in here. Then you have S-bus connectors for your S-bus receivers. You have all the motor wire connectors, M1 to M8. So 8 motors can be connected in this board. Normally we don't use in a quadcopter, we need 4 motors, but also you can connect that. Uh, Regardless of that, you can have 4 LED strips or race wires. In short, you can use race wires for connecting your into a quad that looks pretty in the night. uh, if I just flip it upside down, you will find the SD card reader. The latest SpeedyB version 5 doesn't have a SD card reader. It's gone. I mean, they removed this part because they thought like this SD card is creating a lot of space in the board, and I mean they tried to round about all this and just to made it more compact. Uh, Here you have the FC to ESC connector plug. So stacks, if you see, nowadays you will get a stacks, all like you get Miko Air stacks and F7 stacks. So SpeedyB also has stacks. So if you have a ESC, a 4-in-1 ESC, you can connect directly to this plugs, which is having the connections here from ground voltage 1 2 to 3 4, and This is the C for current and T for threshold. So all these wires are getting connected through one cable and you get the motors. This is the UART connector, S-bus connector here specifically, and you have other sensors like the MEMS sensor and the accelerometer and all that. If I talk about the 20 by 20 flight controller, they look pretty same. The connections are pretty same here. Uh, Only thing is that you need to connect it directly to the you need to connect directly to the pads here. If you see the pads directly to the pads, you can just solder it. So you don't need to worry about space, so you can get a lot of space in the wires. And also you have the type C, so you can directly connect it to the Betaflight. So I'll hook up this one to the Betaflight and I'll show you how this works. So I'll just connect my type C connector here, and we have our bootloader running here. We'll be going to the app.betaflight.com. This basically is the website official for Betaflight right now, which is having the 2025.12 or RC4 or the latest version of the Betaflight running in their website. So you can use this. Once your like FC is connected, sometimes you need to check if your board is not detected. So you should check like I can't find my USB device, and automatically it'll download the drivers for you. Normally you need the ZADIC drivers. I'll put the link in the description below in the video for the drivers which you need for up and running your board. But normally if you don't find it, don't worry, you can easily get it from any of the ZADIC drivers site, or your USB port or USB COM site. So these are mostly the silicon, I mean not silicon, it's USB silicon drivers, something like that. If I don't, Silicon Labs, yeah, Silicon Labs CP210X USB to UART bridge VCV drivers. So this is the page you need to open, and you can find the downloads here, this one. So I'll put the link in the description below, so you don't need to search from there. You can really click at the link and you can find it. Right, so next we should connect it. When you see Betaflight showing up here, you can connect. So this is basically the UI for the Betaflight. So once I move my board, so if I'm moving my board like upside down, you can see the quad also moves upside down. So what that means is that the accelerometer is detecting which direction is your quad is. So for example, if you are flying straight ahead, and this is the nose of the drone, if you're flying straight means you should go straight like this. If the quad is like tilting a little bit on the left, means you give a little bit of a roll and a pitch. So the exact orientation and exact maneuvering can be seen through this 3D file here. It's just a 3D diagram for your animation of your exact board alignment. So if you do click here reset Z axis, it normally resets the Z axis. I mean, you see how it resets the Z axis to the center. Okay, so things here are quite pretty straightforward. You don't need to worry much on changing everything here, but you see the interface. One thing which you need to know is you should always calibrate the accelerometer. That is quite essential, because if you don't calibrate accelerometer, I mean, bad things can happen and the quad may not even arm sometimes. So you should always calibrate accelerometer once you first time once you are doing it. So if you have to place the quad on a flat surface, as it mentions here, and once you see it's a mostly flat surface, you can see the 0 degrees here kind of, and you can hit the calibrate accelerometer. So it will be calibrating the accelerometer here for you. Next, you go to the ports tab. You can find the ports here. This is a small board. It is only 20 by 20 F4 board. It has only 2 UARTs in it. UART 1 is enabled for serial receiver, so you should always toggle it on for your ELRS if you want to give. So every time you're going to give the ELRS or any of the receivers, you have to quit the serial receiving. It's like you're getting the input from the serials. And UR2 is given for VTX. If you are connecting any TBS, Smart Audio, VTX, or even the ISC TRAM protocols, you should always choose that from the peripheral section, and you can use that. But for that, you don't need to use serial RX because it just gets the video from your VTX. Nothing sends really. It just sends to the wireless receivers. Next, you can go to the configuration tab, and here mostly you need to do one change. That if you have LED strip, you can turn it on, and if you have OSD, you can turn it on. I mean, you want OSD from your system, so you want to get the on-screen display, you can turn that on. Remaining, you don't need to worry much in this. One thing I can find is if you are placing your board like upside down, where the arrow markers doesn't suit you, and the arrow markers feel like it's going upside down, so you need to put the board alignment in the opposite direction. So if your board alignment is on the flip side, so you should give a 180 degrees of roll and a 180 degrees of yaw. In that case, the board is gonna flip over and you can set it, and then the quad can be armed and you can fly as usual. But if you're placing it like in the normal orientation, which is the arrow is on the top, so you can just keep it on the 0. Okay, search that, and next we go to the power and battery section. Here we'll find the battery voltage here. So whenever you are having the onboard ADC, whenever the battery voltage you are getting, you can put the cell warnings, battery minimum and battery maximum voltage, and that way you can get the buzz on your onboard ADC when the cell voltage hits the minimum and the cell voltage keeps at the maximum level. So you can set that voltage warnings here. You have the PID tuning. PID tuning tab is where you can play around a lot. I'll make a dedicated video on the PID, specifically for how you can see the Mr. Steele's PID and Joshua Bardell's PID. So they all use a good high rate PIDs for their quads. But what I've used here is a 0.30 expo. If you see all this expo and the rates, so what are all these things? What are expo? What are rates? What are what is the actual rates? Or what is the maximum velocity? What is throttle limits? All this. So I'll dedicatedly make a separate video on PID tuning. It's quite a big topic, so I'll try to make it short. Next, you have the receiver tab, and in the receiver tab you can find when you are connecting your ELRS receiver, the throttle, pitch, and the yaw are moving as it should. You should connect the serial UART via UART if you are giving a ELRS, and here you should choose the CRSF, the Crossfire, a serial receiver provider. If you have S bus, you should go for Spectrum or X bus, or even I bus. You can connect there. Next, you have the modes tab, where you can find all the flight modes: arm, angle, horizon. So all sorts of modes are connected here. You can add modes from here by using add link and add range. So you're using a flip over crash, you can use the add range and you can do the flips. And if you go to the adjustments tab, here you can also put adjustments to your channels specifically like that. Then you have the motors tab. Here you can check all the motors wherever you're running. So for example, if you're testing the motors from 1 to 4, you can choose that, and you can, but make sure you don't have your props on. So that's a very warning. I mean, I warn it very sincerely. Do not use props while you're testing the motors. Always try to remove the props and click on I understand the risk, and then you can turn on your motors and check if they're rotating in the good direction. If not, you can go to the motor direction here. I mean, you can just turn it off and you can get the motor direction here, and you can check the motor direction are connected. The Betaflight will automatically fix that for you. You can reorder the motors as well, and that can be also done from here. That's basically a short video on Betaflight. I'm not going too much in depth on setting the OSDs. I mean, how you can put what angles you can put here, how you can set the video transmitters table and all that. So I'll make a separate dedicated video on Betaflight new version 4.3.1 or even like 4.5 plus, which is the latest one, the 2025 version. I'll make a separate video on that, and even on the LD strips, how you can set LDs, so everything like CLI commands and everything. So I'll separate video. The Betaflight video will be quite, in depth video, so I'll try to make it in that way.